So I want you to picture a really stark visual contrast to start us off today. On one side, you have these images of just raw industrial energy, like massive iron gears, heavy pulleys, steam valves, thick leather belts.
Right, the real heavy machinery stuff.
Exactly, yeah. And then on the exact opposite side, you have these completely silent images representing ideas and modern tech. So computer mouse, fiber optic wiring, atomic structures, compiled code.
Which is such a perfect way to visualize what we're getting into today because, I mean, that contrast is basically the entire mission of this deep dive.
Yeah, it really is. We are looking at this massive high-speed collision between the old rules of business, the gears and pulleys, and the totally chaotic, unregulated frontier of high technology.
And to ground all this, the source material we're working with uses a really specific historical anchor. It focuses heavily on the U.S. Justice Department's antitrust case against Microsoft.
Right, which was just this monumental legal battle. But, and I want to be super clear about this right up front, our goal today is not to play judge and jury on that specific case.
Oh, totally. We're remaining completely impartial on the actual litigation. We aren't taking sides with the government or the tech giant.
No, not at all. We are just using it as a case study, right?
Yeah.
A way to answer this really fundamental question that affects all of us. Basically, what actually constitutes fair play in the insanely profitable world of tech?
Because it's a world that feels like it operates by a completely different set of physical laws.
Exactly. And, whether you're just clicking a mouse at your desk or buying a new smartphone or watching these massive tech conglomerates battle it out on the news, this framework explains why the digital economy feels so alien compared to the rest of the world.
It really does. And to understand the new rules, we kind of have to define the old ones first, right? What the source material calls Marshall's world.
Right, named after Alfred Marshall, the 19th century economist.
Right.
Let's unpack Marshall's world. This is the old guard.
Yeah, it's the traditional economic landscape. We're talking about bulk processing and commodity industries, agriculture, coal, timber, and the example the source uses a lot, the silver market.
Okay, let's use that silver example because I think it makes this really concrete. In Marshall's world, the rules for fair play and monopolies are actually pretty simple, aren't they?
Extremely simple. Because it's based on physical scarcity. If you are a government regulator and you see that a single player has quietly bought up, say, 65% of the entire global silver market, your alarm bells immediately go off.
Because at 65%, you basically control the market, right?
Exactly. The math is undeniable. If you own that much physical silver, you have the power to just lock it in your warehouses, artificially starve the market, and jack up the prices to whatever you want.
You become a monopoly, you gouge the consumer, and the government rightly steps in with an antitrust suit to break you up. It's a very straightforward equation. You count the silver, you find the monopoly.
Right, it's tangible. You can audit a warehouse full of silver bars.
Okay, so let's bring this to the tech collision. Why can't we just take that same math, that 65% rule, and apply it to software? I mean, if a company owns 65% of the operating system market, isn't that just digital silver?
Well, no, and that's the massive rupture in the economic theory. Because high tech is not a bulk processing commodity industry. It doesn't obey the laws of physical friction or diminishing returns.
Right.
Tech exists in this completely new paradigm called increasing returns. And in this world, things are radically more complicated. It's no longer about hoarding a physical product in a warehouse.
It's about dominating an interconnected landscape, right?
Yeah.
Because the fundamental nature of the product is different.
Exactly. Think about the upfront cost versus the production cost. If you want to build a revolutionary piece of software, you might spend 5 years and $100 million on purely speculative research and development.
Just paying engineers, running server farms, all of that.
Yeah, massive sunk costs. But the cost to produce the second copy of that software, or the millionth copy.
It's basically zero.
Functionally zero, yeah.
Fair.
You're just sending electrons over broadband. There's no physical friction stopping you from scaling.
Right, there's no deeper silver mine to dig.
Exactly. And because the marginal cost is zero, the bigger your market share gets, the easier and more profitable it is to get even bigger. But that's only half of the increasing returns equation.
Right, the other half is how the product actually behaves out in the wild. Like in Marshall's world, a brick of silver is just a brick of silver. It doesn't magically become more valuable. just because your neighbor also buys a brick of silver.
They don't interact. But tech products, especially software and networks, they absolutely do interact. They rely on network effects.
Which means the utility of the product actually goes up every time a new person uses it.
Exactly. An operating system is totally useless if you're the only person on Earth who has it. But as more people adopt it, more developers write apps for it, more hardware is compatible with it, and its value just skyrockets.
So the market doesn't naturally settle into this nice, balanced equilibrium where 5 different companies all have 20% of the market.
No, it violently rejects equilibrium. An increasing returns market actively wants a single winner to emerge so everyone can be on the same standard. And when one product achieves that runaway dominance, the market enters what economists call lock-in.
Lock-in. Okay, that sounds really ominous, like we're all just trapped by one company.
Well, it is highly restrictive, but the source material actually spends a lot of time debating the pros and cons of this lock-in effect. It's not all bad.
Yeah, let's break that debate down because the text splits this into 4 distinct pillars. And the first one, surprisingly enough, is the pro. It's convenience.
Right, which sounds so counterintuitive if you're used to hating monopolies. But a single locked-in standard avoids what the source calls a tedious hodgepodge of conflicting protocols.
Hodgepodge is a great word for it. I mean,
Yeah.
think back to the early days of computers before everything was standardized. It was a nightmare.
Oh, excellent.
If you wanted to do something as simple as check your bank account online, you couldn't just open an app. You had to manually configure your modem, make sure it had the right driver for your specific motherboard, dial into an ISP using some proprietary connection protocol, and hope it could translate the data to the bank's totally separate mainframe.
It was exhausting. The friction was so high that it was barely usable for the average consumer.
Exactly. So the massive pro of a locked-in standard, say, a single dominant operating system that controls the screen, the hardware connections, everything straight through to the bank account, is that it eliminates all that translation.
Yeah, the Microsoft example used in the text highlights this perfectly. Controlling the whole stack allows the user to just seamlessly double-click an icon and get to their money. You don't waste time navigating a succession of online connection protocols.
Right. It just works. The convenience is undeniably huge. But of course, that brings us to the second pillar, which is the major con, technology development.
Yes. The argument here is that the exact same lock-in that makes your life convenient today can actually freeze technological progress for tomorrow.
Because it establishes this architectural ceiling, right?
Exactly. Once a standard locks in, the entire global ecosystem contorts itself to fit that standard. The switching costs become astronomically high.
The source brings up a really great historical example of this with DOS, the early disk operating system for PCs. Let's talk about DOS.
DOS is the perfect case study. In the early 80s, through a mix of business savvy and historical accidents with IBM, MS-DOS became the absolute default locked-in operating system for personal computers.
And once it was locked in, every software developer had to write their programs for DOS or no one would buy them.
Right, but here's the kicker. Structurally speaking, DOS wasn't actually that great. It had severe limitations with memory management and multitasking, but it held the entire PC market in a chokehold for 10 years.
10 years. So wait, if you're a brilliant engineer in, say, 1988,
Yeah.
and you invent a vastly superior, faster, more secure operating system, it doesn't even matter.
It's basically dead on arrival. No hardware manufacturer is going to install your brilliant new OS because it can't run the millions of lines of legacy DOS software that businesses rely on.
Wow. So the success of one technology literally impedes the development of better alternatives. We lose a decade of potential progress just for the sake of standardization.
It's a massive trade-off. And that leads directly into the third pillar of the lock-in debate, which I think is the most surprising one.
Yeah, this is where it gets really interesting to me. The third pillar is pricing. Because in Marshall's world, the whole fear of the silver monopoly is that they'll gauge you on price.
Right. Predatory pricing is the classic antitrust fear.
But in the tech world, that assumption gets completely flipped on its head.
Yeah.
Monopoly pricing isn't the main fear here. Why is that? If a company has a total lock-in, why don't they just triple the price of their software overnight?
Well, you have to look at how they achieve the lock-in in the first place. Because of network effects, tech companies have to capture maximum market share as fast as possible. To do that, they use penetration pricing.
Meaning they heavily discount it.
Heavily discount it, bundle it, or often just give the core product away for completely free. The goal isn't immediate profit, it's ubiquity. They want everyone in the network.
Okay, but once they have ubiquity, once everyone is locked in, why not raise the price then?
Because of the legacy install base, this is unique to software. It doesn't wear out like a pair of shoes. It's just code. So if a dominant company suddenly demands a massive price hike for the new version, the consumer has a powerful defense.
They just don't upgrade.
Exactly. They just keep using the old locked-in version indefinitely. The company's biggest competitor is actually its own past product.
That's wild. So the classic bulk processing fear of price gouging doesn't really apply. The software stays cheap or free to maintain the lock-in and deter competitors from entering the market.
Right, which forces regulators to look at something much more ambiguous. If the consumer isn't getting hurt by high prices, the focus shifts to the fourth pillar.
Fairness. Fairness. This is the gray area, because the question becomes, when is market dominance genuinely earned, and when is it essentially stolen?
And that's the razor's edge of tech regulation, because if a product locks in purely because it's just superior, the code is faster, it crashes less, people genuinely prefer it, then penalizing that success is totally foolish.
Right, that's just a free market working correctly. If you build a legitimately better mousetrap, you should get the reward.
Exactly. It's genuinely fair.
But, and here is the major counterpoint from the source. What if a company doesn't win because their new product is better? What if they only achieve lock-in because they levered over their massive user base from a neighboring already locked-in product?
Yes, leveraging. This is the core mechanism of anti-competitive behavior in software.
I mean, logically, that feels inherently unfair.
Right.
I mean, it totally sidesteps the meritocracy of the market. And it sets up this incredibly complex regulatory challenge. How do you even police that?
Well, to police it, you first have to completely redefine how you visualize dominance. We're moving out of Marshall's world entirely now.
Right, into Section 3. The anatomy of tech dominance.
Yeah. In this increasing returns world, dominance doesn't look like a single giant silo of silver anymore. The source uses a much more accurate visualization. It looks like a spider web.
The spider web, let's unpack that.
It's a vast, interconnected web of technology. Dominance is measured by taking over more and more threads of that web.
So if the operating system is the thick, structural thread right in the center of the web, the company doesn't just stop there.
No, they extend a thread to capture the web browser. Then they spin a thread into search algorithms, then digital advertising, cloud storage, email protocols.
And each new thread they capture reinforces the strength of the whole web. It makes it harder and harder for anyone else to compete.
Right, because everything is vertically integrated. To the user, it's highly convenient. But to a competitor, it's an impenetrable fortress. You'd have to replicate the entire multi-billion-dollar web just to compete on one single thread.
Which brings up the real danger of the web. What happens when one company owns too many of these threads? I mean, beyond just protecting their current monopoly.
The consequence is that it prevents other players from getting access to new breakout markets.
Breakout markets, like totally new paradigms.
Exactly, like the shift to mobile computing or the shift to cloud infrastructure. These are the rare moments where the whole game resets.
Right.
But if one giant company controls all the underlying threads, the APIs, the user data, they can see that new market forming, rapidly build a clone of the new tech, and use their existing web to push it to 1 billion users overnight.
They literally siphon all the oxygen out of the room. They starve the independent startups before they can even get off the ground.
They preempt the future.
Which is a terrifying thought.
Yeah.
And it places this massive burden on government regulators to stop it, which, let's be real, is an absolute nightmare for them.
Oh, it's practically an impossible job.
Yeah, let's discuss why it's so impossible. First of all, just defining the market.
Right. Market definition is the first hurdle in antitrust law. In Marshall's world, it's easy. A car is a car, a lump of coal is a lump of coal.
But in the digital spiderweb, where does an operating system end and a web browser begin?
Exactly. The boundaries are entirely fluid. The tech companies intentionally blur those lines. They argue that a browser isn't a separate market, it's just an integrated feature of the OS.
How is a judge supposed to legally untangle millions of lines of interwoven code?
Often, they can't. Legally separating the products might technically break the software itself. But even if they manage to define the market, they hit an even worse problem.
The pacing mismatch.
The temporal reality of the legal system versus the tech industry.
Right. I always compare this to trying to referee a sport where the players are literally inventing the rules, the ball, and the field while the game is already being played.
That's a great analogy. The tech landscape mutates every few months. By the time a government agency investigates, files a massive lawsuit, goes through discovery, handles the appeals, and gets a final judgment.
A decade has passed.
A decade. By the time they order a breakup of a desktop OS monopoly, the entire world has already moved on to smartphones. The market they just spent 10 years fighting over literally doesn't matter anymore.
They are permanently fighting the last war. The tools of Marshall's world are just too slow and blunt for the digital spiderweb.
Exactly. So how do we handle this? That brings us to Section 4. The author of the source material proposes a specific framework for this.
Right. Based on all these complexities, the overarching recommendation is actually a stance of deep regulatory restraint.
Yes. On balance, the default posture of the government should be extreme hesitation to intervene.
Which might sound crazy given everything we just said about the dangers of the spiderweb. But this restraint isn't just a free pass for the tech giants, right? It's conditional.
Highly conditional. It must be paired with two non-negotiable principles, two golden rules for the digital age.
Let's get into Principle 1. And this one really challenges a lot of the standard regulatory instincts. Principle 1. Do not penalize success.
Right. The philosophy here is that short-term monopolization in an increasing returns market is not actually a crime.
It's the reward.
It's the prize for innovation and massive risk-taking. If a company risks hundreds of millions in R&D and builds a standard the whole world adopts, you shouldn't punish them for winning.
I love the analogy the source uses for this, the Old West Saloon analogy.
Oh, yes.
Because regulators, when they see a really powerful new tech giant, they get this temptation to just treat it like a saloon brawl. You know, if you see a head, hit it.
Right, whack-a-mole, antitrust policies.
Yeah, exactly. But why is that so disastrous here? I mean, why not just hit the biggest guy in the room?
Because hitting whoever pops their head up destroys the incentive to innovate in the first place. If you establish a rule that achieving massive global success guarantees the government will spend a decade trying to tear your company apart.
Why would anyone take the risk?
Exactly. Venture capital dries up. The rational strategy just becomes engineered mediocrity. Keep your head down, make minor updates, but whatever you do, don't invent the next revolutionary platform.
Because becoming too successful makes you a target. Okay, so Principle 1 says, put the hammer down, let the winner have their prize. But there's a limit.
A strict limit. And that's Principle 2. This is about how the empires are allowed to behave once they've won.
Principle 2. Don't allow head starts for the privileged.
To explain this, we need another frontier analogy from the text, the land rush.
Okay, walk us through the land rush.
When a new paradigm opens up, like the dawn of electronic consumer banking or AI, it's like a chaotic, wide-open race to claim the new territory.
Everyone lines up at the border, the gun goes off, and you run.
Right. And Principle 2 says, companies that already dominate an older market, like an operating system, cannot be allowed a 10-mile head start in this new land rush.
Ah, this connects right back to what we were saying about fairness and leveraging.
Exactly. You can win the new race because you're fast, because you have the best engineers. But you cannot win just because your previous monopoly let you start 10 miles ahead of the independent startups.
Right. You can't structurally sabotage the other runners by denying them access to the core infrastructure. All competitors must have fair and open access to the applicable technologies and standards.
Which totally shifts the government's role. They aren't trying to break up the winner anymore. They're just the referee at the starting line, making sure nobody is cheating before the gun goes off.
It makes a lot of sense. But applying these two principles practically leads us to a really uncomfortable conclusion for society. This is Section 5, the starting line.
Yeah, this is the grand bargain of the tech age. To accept this framework, we essentially have to accept the possibility of winner-take-all lock-ins.
In each new sub-industry, in each new wave of technology, we have to accept the monopoly.
We do. We trade the fragmented competition of Marshall's world for the seamless convenience of the digital lock-in.
But, and this is the massive caveat, the only way society should accept that bargain is if every single contender has access to the exact same starting line.
The same technologies, the same open standards, to whatever degree possible.
Right. And the source text actually frames this as a pretty stark ultimatum to the tech industry itself, voluntary versus imposed.
Right. The industry has a choice. If they self-regulate, if they voluntarily maintain open standards and let startups interoperate without structural sabotage,
Then the government follows Principle 1. They exercise restraint and leave them alone.
but if they refuse, if they aggressively use their locked-in webs to build moats and crush nascent challengers,
Then what?
then they leave the government with no choice. The state will abandon restraint, step in, and impose those fair provisions through heavy-handed, aggressive regulation.
They'll treat them like public utilities, which, as we discussed, causes endless litigation and basically cripples the pace of innovation for everyone.
It's the ultimate standoff. Keep the starting line fair voluntarily, or the state drops a regulatory bomb on the whole ecosystem.
Wow. Okay, so just to synthesize this whole journey we've been on, we started in Marshall's world, doing the simple math of the silver market.
Counting physical bricks?
Right. And then we moved into the tangled, invisible web of high tech. We discovered why free software isn't necessarily fair play and why stopping a monopoly can actually be just as dangerous as letting one thrive.
It's a completely inverted economic reality.
It really is. Now, before we sign off, I want to leave you, the listener, with one final provocative thought based on this logic.
Something to look out for.
Exactly. Think about the next massive, undefined frontier in technology, the stuff that hasn't even fully formed yet.
Spatial computing, neural interfaces, advanced artificial intelligence.
Right. If a completely new land rush for that tech begins tomorrow, ask yourself, who currently has the power to quietly build a 10-mile head start?
Who owns the cloud infrastructure, the data centers, the mobile OS?
Exactly. What neighboring threads are they pulling right now, deep inside their code, to guarantee they lock us all in before we even realize the race has begun?
It's the question that will define the next 50 years of the economy.
It absolutely will. Well, thank you so much for joining us on this deep dive. We hope it helps you look at the tech you use every single day through a totally new lens.
Until next time.